How do you navigate NEC and IEEE grounding system codes? Imagine wiring a building or designing a power system without knowing the rules that keep everything safe. That's where understanding the differences between the National Electrical Code and IEEE standards becomes essential. These two sets of rules guide how we connect and protect electrical systems, especially in power distribution and renewable energy projects. The National Electrical Code, or NEC, is a regulation focused on safety in buildings and installations. It explains how to connect grounding wires to ensure fault currents can safely return to the source. The NEC emphasizes using equipment grounding conductors, which are copper or aluminum wires that connect metal parts to grounding electrodes like ground rods or water pipes. These electrodes help stabilize voltage and dissipate static or lightning surges. But the NEC clearly states that the earth itself is not a reliable fault current path. Instead, fault currents must flow through the grounding conductor to trip protective devices and prevent shocks or fires. On the other hand, IEEE standards, such as IEEE Standard 80, are more about engineering design. They focus on creating grounding systems in substations and industrial plants where large fault currents are expected. IEEE practices assume that fault currents will flow into a grounding grid or mesh buried in the earth. This grid is designed to control voltage differences on the surface, reducing dangerous touch and step voltages. Unlike the NEC, IEEE treats the earth as an active part of the fault current path. It considers soil resistivity and the size of the grounding grid to safely dissipate energy during faults. To navigate these codes effectively, start by knowing their scope. The NEC applies broadly to electrical installations in buildings, ensuring safety and compliance. IEEE standards are used for designing grounding systems in power plants, substations, and renewable energy setups. Recognize that the NEC prioritizes equipment grounding conductors and electrodes for fault clearance. IEEE emphasizes designing grounding grids that manage fault currents and voltage gradients. When working on a project, always refer to NEC Article 254 Grounding and Bonding Rules. This covers conductor sizes, electrode types, and bonding methods. For designing grounding grids in substations or renewable energy plants, follow IEEE Standard 80. This involves soil resistivity testing, conductor sizing, and setting limits for step and touch voltages. Material choices also matter. The NEC allows copper, aluminum, or copper-clad aluminum for grounding conductors, with corrosion resistance being key. IEEE guidelines specify conductor sizes and layout to ensure the grounding system performs well under fault conditions. Always coordinate with local electrical codes and utility standards, which might incorporate both NEC and IEEE requirements. In power distribution and renewable energy projects, use NEC rules to meet safety codes and IEEE standards to optimize system performance. Properly combining these approaches helps create grounding systems that are safe, reliable, and compliant. Understanding how these codes complement each other allows engineers to design systems that protect both people and equipment during faults.